Woohoo, guys! Today is that day that we've been working for like, what, 2 weeks now, trying to figure out why atoms form the particular ions they do, why they only like to gain 2 electrons and not gain 3 or not just gain 1. Um, and so that's what we're dealing with today is just getting right to that point. And so we're going to start back with our electron configuration that we covered um, last week. And so I am just going to use that electron configuration to draw some Bohr diagrams. So remember I said, although Bohr's electron model or atom model isn't necessarily the most correct one, it is really nice for pictures and seeing what's going on in our energy levels. And so we're just going to draw some pictures. And so I have our energy levels. This is my nucleus in here. And then these energy levels represent the energy levels within the atom where we could find electrons. Now we're not worried about sublevels because that's really messy drawing. And so we're just going to put them into the energy levels. And so I'm going to start with chlorine. And chlorine, we said, fills in this order. It first puts electrons in the 1s energy level, and it puts 2 there. And so we're going to go ahead and put 2 electrons in that first energy level. That's all that really goes in there because then we fill our 2s energy level. And so we put 2 electrons in there. I'll go ahead and use another color to show that I'm filling the p orbital. And so in the second energy level, so I'm going to stay in that second ring, the second energy level, I'm going to put in 6 more electrons. All right, and then I'm going to fill the third energy level, and I'm putting in 2 into my s orbital. And then I'm putting 5 into the p orbital. And so 1, 2, 3, 4, 5. All right, and so looking at this, it looks like I have 2 electrons in the first energy level because I have 1, 2. In the second, it holds 2, 4, 6, 8, and so there's 8. And then there's 2, 4, 6, 7 in the third. And so again, that's just how many electrons I have in each of those energy levels. Let's go ahead and do like sodium now. Sodium, maybe I will do sodium here in a minute. Let's do manganese. And so manganese is right here. It's one of those that's one of our transition metals. And so this will be a nice example for later. And so I have that I'm filling 1s2. And so I'm putting 2 electrons in that first energy level. And then I fill 2s2. And then I'm still in that second energy level, but it's going into my p orbital. All right, and then moving on to the third energy level, I put 2 into the s. And then moving on to the p orbital, but it's still in 3, I'm putting in 6. Okay, and then I'm into the fourth energy level now. I'm filling 4s2, and I put in 2 electrons. All right, then notice it jumps back inside, back to the third energy level. And so it's going to fill in the third energy level with a few more electrons, and it's going to fill in with 5 more. Right, so there's those 5 extra electrons. And so notice now that in the first energy level, I have 2, and then I have 8. And then I have 2, 4, 6, 8, 10, 12, 13. And then I have 2. Right? This is actually on our periodic table, and this is really nice. So instead of drawing stuff out, we could look at these numbers. Again, it's on your periodic table, and if I can do this rather than switching screens, it shows you that for chlorine, so right over here on this little side here, right there, 2, 8, 7. And so notice we had 2, 8, 7. And so it tells you how many are in the first energy, second, third. All right, and then we can compare with manganese. Manganese is right here, and it says it's 2, 8, 13, 2. 2, 8, 13, 2. And so you can use your periodic table for this now. We don't have to worry too much about writing out electron configurations because we know how many are in each energy level there. right? And so what is going to be the most interesting to us is actually the valence electrons. And so valence electrons are the number of electrons, or are the electrons in the outermost energy level that is filled in your atom. And so in chlorine, the highest energy level it fills is energy level 3. And so these electrons right here are called valence electrons. Chlorine has 7 valence electrons. Right? Manganese here, manganese has 2 valence electrons because the highest energy level it fills is energy level 4, so it has 2. Right? We could look at things like sodium, and sodium, we'll just use our periodic table. It says 2, 8, 1, and so it has 2 electrons, and then it has 8, and then it has 1, and so it has 1 valence electron. Right? And then we could do another one like, let's do oxygen. So oxygen's over here, and it says it has 2 and then 6. And so it has 2 electrons and then 6. And so it has 6 valence electrons. All right, so why is this important, or why do we look at valence electrons? Well, valence electrons, we have seen, ties our elements together based on properties. And so one thing that we should notice looking at our periodic table is that everything here in group 1 has 1 valence electron because they all fill that highest energy level in the S with 1 electron. All of these have 2. All of these have 3 valence electrons, 4 valence electrons, 5 valence, 6 valence, 7 valence, 8 valence. And so our periodic table arranges these by valence electrons. Again, this is kind of because of the properties we see these elements share in those columns. And so if I were looking at everything in group 1, everything in group 1 has a special name, which is alkali metals. And so right here we see these are our alkali metals. All these alkali metals have 1 valence electron. They tend to form charges of 1 plus, and they are very reactive. Oh, very reactive. All right. In column 2, these are our alkaline groups, or alkaline earth metals, and they have 2 valence electrons, form a 2 plus charge when they form ions, and they are just reactive, so not very reactive, just kind of reactive. And so we see highly reactive, a little less reactive, and group 13 is still a little less reactive than group 2. Right, going to the other side, in group 17, we have halogens, and so that's these ones right here. They have 7 valence electrons, form a charge of 1 minus when they form ions, and guess what? Very reactive, right? And then this one's not listed below, but this is group 16. They have 6 valence electrons, and they form a 2 plus charge. These ones are less reactive than group 1. Or group 17. When these things react, they oftentimes react very explosively and very quickly. These ones require a little bit more time when they react. And then these ones even more. So these ones have to form a charge of 3 plus. Right, and then we have one more group, which is our noble gases. And so our noble gases are right here. They have 8 valence electrons. These things do not react. They don't like to react. They're very stable. They like to be alone. You know, a lot of these elements here, they are diatomic because they're so reactive. These guys are like, whoop, cool by myself. And so what makes them that way is that they have 8 valence electrons. And so what we've seen is that everything else is actually trying to be like a noble gas. You know, we've talked about this group right here. They all have 7 valence electrons. They all like to gain 1 electron. They like to form that 1 minus charge. Well, what's happening? They're becoming a noble gas. They're filling an octet. They're getting 8 valence electrons. And so we could look at the Bohr model of the atom and see that. You know, chlorine likes to gain one electron. He wants to gain that electron. He wants to be a 1 minus. And so when he does that, when it gets in that extra electron from someone else, guess how many electrons it has? It doesn't have 7 valence electrons now. Now it has 8. And it forms that 1 minus charge. All right, so what about sodium? Sodium likes to lose 1 electron. And so let's say he got rid of this one. Well, now the valence shell is this right here. And so how many valence electrons does he have? He has 8, just like a noble gas. These things are becoming noble gases. And these ones are very reactive because all they have to do is gain or lose 1 electron. If we were looking at oxygen, oxygen has 6 valence electrons. So to become a noble gas, he has to have enough energy to take 2 more electrons to get 8 valence electrons, forming his 2 minus charge. And so all those charges came from filling that valence shell, how many they have to get to become a noble gas. And so looking at our periodic table, everything in group 1 loses an electron. So they could make some choices. Instead of losing 1, it could gain 7, but it's going to take so much energy to gain 7 electrons that it's not going to do it. It's going to take the easy way, the lowest energy requirement, and it's going to lose 1 electron to become like neon. Okay, magnesium, the second group, anything here, could gain 6 electrons to be like argon or the other noble gas, or it could lose 2 electrons to become like neon, which again, it's going to take less energy to lose 2 than gain 6. And so that's what it does. It loses 2 electrons to become neon, forming that 2 plus charge. Everything in group 3 could lose 3 or gain 5. Well, yeah, it's going to lose 3 electrons and become like a noble gas. Right, fluorine, again, this is group 17. It's going to gain 1 to be like neon. It takes way too much energy to lose all 7 valence electrons, so it'd rather gain 1 to be like a noble gas. Again, these guys are going to all gain 2 to be like the noble gas. These ones are going to gain 3. And so this column we said can go either way because, well, it doesn't matter. Is it easier to lose 4 electrons or gain 4 electrons? And so that's why this column goes either way. And it turns out these top ones are going to like to gain, and these ones down here are going to like to lose because of the type of atom they are and their electronegativity, which you'll learn about later. But yeah, so this is why they form those. They're trying to become like a noble gas. They're trying to gain that configuration. And so we have one more situation to look at, which was this middle region here. And so this middle region, again, can form multiple charges. And so one example we did was manganese. Manganese is right up here. And so it's in this block. Now, manganese can form multiple charges because, yes, it has 2 valence electrons, which it could lose and form a 2 plus charge, but it also has these extra electrons that filled the 3d orbital. That orbital is actually a little bit higher than this s. And so instead of losing these electrons, it could lose these. And so it could lose 2 of them, it could lose 3 of them, it could lose 5 of them, it could lose a combination of these 2. And so that's why our transition metals form multiple charges, is because they have more orbitals in which they could lose electrons. Because even if they lose them, it's still going to have a full valence shell. And so yeah, they can lose multiple electrons in there. One thing you might notice looking through here is that most of these will have 2 valence electrons because they fill the s orbital and then they jump back inside. And so you'll see a lot of them have 2. And so a lot of these things do form a 2 plus charge. There are some instances where they fill orbitals in different orders. So just be aware that that can happen and that some of those numbers might not agree with what you think, which is completely okay. We don't need to worry about that. Most of these have 2 valence electrons, but they can lose multiple amounts of electrons. Okay. So yeah, so looking at valence electrons, that's the explanation as to why we form the ions we do and why they form the charges that they do. They're trying to form that noble gas electron configuration to become stable like our noble gases. Right? Have a great day. Bye.